Hey guys, Mr. Falcucci here. Just wanted to make sure we went over this orange trees problem before your quiz tomorrow, which is Friday the 13th. So we have a little prompt right here. Study examine the number of trees in a variety of orange groves and the corresponding number of orange that each grove produces in its harvest is in a given year. Okay, linear regression was run and the results are below. So we're talking about here, right? My dependent variable oranges, my independent variable is trees, meaning my explanatory variable is trees. My response variable is oranges. All right. We have our sample size. We can see what r squared is right here. Okay. We have my parameter, which is my constant, which is going to be my y estimate, my y-intercept. Okay. Trees, we already said as our explanatory variable. Okay. So here's my slope. And here is my y-intercept. All right. So if we look at question number one. Question number one says, write the regression equation, define all variables. Define all variables means, okay, is put it in context, right? So we already said that our response variable is orange, so we're talking about predicted oranges, right? We have our slope, our y-intercept, 390.59, and our slope, plus 525.84 times, right, the amount of trees that we have. All right, so oranges hat, the predicted amount of oranges, 390.59 plus 525.84 times the amount of trees that you have in your grove. Interpret the slope in context. So, according to the model, for each additional tree, right? So we're talking every time our explanatory variable goes up by 1. So every time we add a tree, right, it is predicted that the number of oranges harvested will, now our slope is positive, so it's going to increase by 525.84. Interpret the y-intercept in context. According to the model, okay, when there are 0 trees, so when our when our explanatory variable trees here is 0, okay, it is predicted that 390.59 oranges will be harvested. All right, now in this context, does that really make sense? Not really, because, how can you harvest oranges if you don't have any orange trees? But again, that's what the model is predicting. It's kind of the starting point for our line right here. All right. If we continue on here, it says, oh, sorry, too far. Interpret r squared. Why is r squared not 100? So we go back to the beginning right here. We have r squared is 0.886. Okay, so if we're going to interpret it, right, 88.6%, we're going to start it out with this percentage of the variability in oranges harvested is accounted for by the variation in trees, right? Number of trees in your grove. All right. The farmer with 35 trees ended up getting 15,400 oranges, okay? Find the value of his residual. Is he pleased or displeased with the residual? So remember, our formula for residual here is E equals Y minus Y hat. So our actual value minus our predicted value. So I know, starting out right here, I know that my actual value was 15,400. What I don't know, right, there's my actual value right here. What I don't know is I don't know what my predicted value is, but I can use the equation to figure out what my predicted value would be. Okay, so I know that my equation I had was predicted oranges is equal to 390.59 plus 525.84 times trees. And we just said, right, that we're going to plug in 35 trees. So my predicted oranges here, right, if we have 35 trees, 390.59 plus 525.84 times 35. So if we do that out right here, we get our predicted oranges here. So our predicted oranges is equal to 18,794.99. We'll round that up to 18,795. Okay, so that's what the model predicted for us to get. So now I know what Y hat is. I can put in my predicted value right here, 18,000, okay, 795. So here my residual, so 15,400 minus 18,795. Okay, I have a residual of negative 3,395. Okay, so I have a negative residual, okay, which means the model has over predicted. Okay, so in this case here, is the farmer pleased or displeased with the residual? Okay, the farmer is displeased, right? And he's displeased, okay, because based on the model, he was expecting to get 3,395 more oranges than he did. Right, so in this case right here, he performed well below the model, what the model would predict for somebody with 35 trees. Okay, so in this context right here, he is not happy with that negative residual. He was expecting to get 3,395 more oranges. And then finally, to finish up here, find the correlation coefficient. All right, so if we think about this right here, right, our correlation coefficient is R, and then we have our other variable which is R squared. So if I know that R squared is equal to 0.886, right, couldn't I just take the square root of that, okay, to find what R is? So R here, so R is equal to the square root of 0.886. So if we do that out on our calculator, okay, we get R is equal to about 0.941. All right. So I hope that was helpful. If you have additional questions, please shoot me an email or let me know. Reminder, your quiz tomorrow. I'll be posted all day for you on Chapter 7. You guys seem like you're doing really well with this. Good luck. And I'll see you guys at our Friday morning check-in.